Welcome you all to the video lecture of Introduction of Electrical and Electronics Engineering. So in the previous video lecture we have discussed regarding to the top the laws of the electromagnetic induction in the AC fundamentals. So the codes are related to the top CO1 where we are going to apply the basic laws on the simplification techniques in order to get using over the electric circuits with respect to the top electrical engineering. So now we are going to discuss about to the topic related to the generation of a single phase alternating EMF and its terminology, which means that the single phase alternating EMF we are going to discuss over here in this video lecture. Okay, so initial part we are going to discuss with respect to the generating, how we are going to get generating over this alternating EMF. Let us here we are going to consider a coil where we are going to take the number of turns as a n. So the n is the number of turns where it get be placed over in the top the magnetic field of the conductor, or else it takes place in the coil. So the normally this magnetic field has the maximum value of the psi m. So here the psi m returns to the top the maximum value in terms to the top of above. So here the coil where get be initially along with the reference axis, whereas in that condition the field is automatically get perpendicular to the top the plane of the coil, which means that here this magnetic field is in the condition of the perpendicular condition with respect to the top the plane of the coil. So now after considering those things, let the coil be rotated in the top the anti-clockwise direction. So not in the clockwise direction, it get rotate over in the anti-clockwise directions. So right hand side to the top, the left hand side, it is in that condition of the anti-clockwise directions. Okay, so after that here they are considered that the reference axis, whereas the omega t is equal to 0. So in this condition it is in the state of the 0 EMF position. So this is why, because it get obtained is the movement of coil in that instant is, whereas the omega t is equal to 0 with respect to the top the magnetic field. So at that condition the with respect to that field the omega t is equal to 0. After to the top the zeroth condition, whereas at the any time instance means 1 or 2 3 any time seconds, that coil will be take places in the top position with respect to that figure in that upcoming slide, like this in this figure. So initially it is in the top zeroth position. After considering to the top n terms with respect to the time, so here it is in that place of 45, it is in the different location, whereas considering that initial stage. So that is has been mentioned over here in this point. So at that time instant the coil makes an angle of theta, whereas that time the theta is equal to omega t. So which means that here you can consider this conditions. So at the 45 time instant it will create some angle, so that angle is going to be say that as a theta. So that has been mentioned over here, that theta value is equal to omega t. So after that the normal components where we get involved out for this magnetic flux with respect to the top ends of the plane of a coil will be equal to that of a psi m into cos theta, whereas this theta says us to the top the omega t. This omega t is that coil making angles, which means that the coil makes some angle, so that angle is going to be give with respect to the top values the omega t. After considering over or all those things as that for a normal component the equation is going to be given with terms of the psi m into cos omega t. This is for the normal component equations. Whereas now we are going to get consider over the two terms such as the flux linkages and instant point. During that conditions, which means that during that flux linkage condition, we are going to give the expressions will be equal to the top n psi m cos omega t, or else cos theta. So it also can be able to get written over n psi m cos theta. Here this theta value will be obtained from where? The omega t, which is mentioned over here. So like with respect to the top turn, it get be obtained with respect to which law? It is obtained with respect to the top the Faraday's law. Okay, So after considering all those things, which means that the flux linkages and the time instance, the equation is going to be get modified over to E is equal to minus d psi divided by dt. Here the psi is flux linkages is obtained with respect to that of equation, which means that the formula, so psi is equal to n psi m cos theta. So this theta will be changed over to omega t. Therefore E is equal to minus n flux linkage psi m omega sin omega t. So this minus and minus will be get cancelled over there. So and that it gives us the value of the n psi m sin omega t. So therefore the E is equal to, which means that here this E value will be equal to n psi m omega sin omega t. So this is the value will be obtained with respect to that of this Faraday's law. So the EMF induced in that coil will be given with respect to that of this formula. Okay, now we are going to change over the condition with respect to that of the some angle. So here in the previous slide we had discussed regarding to that of this angle theta is equal to omega t. So at initial condition it is in the 0th position, whereas here after that the with respect to that time instance the angle will be get changed over anywhere. So here with respect to that of this induced EMF E is equal to n psi m omega sin omega t, we are going to place the angles and we are going to get obtain over the values, whereas this omega t 0, 180 degree and 270 degree we are going to get import over these values over here, whereas the sin 0 we are going to get value as a what, we are going to get the value as a 0, and for else for the sin 180 degree also is good, we get 0. So that for with respect to that of the omega t, which means that the theta value is equal to 0 or 180 degree means automatically the induced EMF is equal to 0, whereas with respect to that of 90 degree and 270 degree we are going to get the value with respect to that of induced EMF is equal to n psi m omega, and whereas for the 270 degree it will be get value as a let for the sin 270 degree we are going to get the value as a -1, for else the sin 90 degree we are going to be get the value as 1, sin 270 degree we are going to be get the value as a -1. So these two things is get taken place over here and gives us the, here it gives positive value, which means that the sin 90 degree is equal to 1, whereas here the sin 270 degree gives us the value of -1, so that only it will be get over here as a minus sin n psi m omega. Oh, so with respect to that so n psi m omega it will be equal to that of the induced EMF. Let with respect to that of denoting the maximum value of the induced EMF from the above equation, we can write able to get change over this equation E is equal to Em sin omega t, whereas this Em will be the magnitude value. So Em minus Em to plus Em, which means that it has both positive side value and the negative side value will be get changed over with respect to the of the omega t. So they are this t is the major constraint, time constraint will be taken places over here, which means that at the particular time instance the wave is not going to be get constant over there, it will be in the fluctuating stages. So from the 0 degree to 360 degree the full cycle the value is going to be get import with respect to the induced EMF is equal to Em sin omega t. For the alternating EMF for a one complete cycle we have gone over here with respect to the formula or else an equation E small e induced EMF is equal to Em sin omega t. Now the various terminology is going to be get import over here in this alternating current terminology, such as waveform, alternating waveform, and periodic waveform, sinusoidal, non-sinusoidal waveform, cycle and amplitude. So frequency, period, phase and the phase difference, these are the things as will going to be get declared over here with respect to the any waveforms as sine, rectangular waveform, triangular waveform. So like this we are going to see what is mean by waveform, alternating waveform, time, amplitude, phase, all those things, etc. So that normally a waveform is a term which will be going to be used for to show graphically a alternating current value, which means as alternating current means alternating at any point the value is not in the constant condition, it will be in an alternating state, which means that it is in a alternating state, not in a constant time, which means that constantly it is not in that value, it will be in a fluctuating value. So another is the alternating waveform. So here this is it is in the reverse into that of directions, which means that here this wave is normally in the condition of the reverses its directions at regularly recurring time intervals, which means that here this A and B shows us to that of the alternating waveforms. So the next conditions are such as the periodic waveform, sinusoidal, non-sinusoidal waveform. So periodic waveform is where it will be, which means that one which repeats itself after the definite time interval, which means that like this, at the zeroth condition it is in the value of 2, and 1 2 3 4 time periods it also in the condition of the 2. So this is the periodic waveform, whereas the sinusoidal and the non-sinusoidal waveforms is associated with respect to that of like this. So at the condition 0 it is in the place of 1, whereas in the 1 in the condition it is in the place of 1 value. So like this it will be in that change, like this in that conditions it will be in that conditions. So and that cycle, so here the cycle is says to that of a covering of both positive and a negative value. One complete set of positive and negative value constitutes as a cycles, whereas the amplitude, which means that it says to the height of the waveform, which means that here this is like to say that an amplitude. So maximum positive or negative value of an alternating quantity is called to be said as amplitude. So the next terminology is the frequency, which means that here this frequency terms, just for an example I am going to replace one sinusoidal waveform. Here the number of cycles is obtained per second with respect to the of alternating quantity. So let's, for an example, here the unit for the frequency is expressed in the terms to the top of hertz. Next is the time period. So period means a period also it going to be defined the same thing for the time period. So let, for an example, the time period of an alternating quantity is the time automatically or else taken to complete one cycle, which means that for completing one cycle it is going to say that time period value. Phase, the phase terms tells to that of the positive and negative phases. Here this term tells us about the positive phase, and here this term tells us about that of a negative phase. The first difference means comparing the phases of the two waveform of an alternating quantities. So the next is a generation of the single phase alternating EMF. So now we are going to get considered over the two coils such as A dash based on coil and B dash based on coil. Here this is A dash coil producing such a waveform. Here this B dash based a coil producing a sinusoidal waveform. Here let make going to consider this two coil be rotated with the same angular velocity, which means that here these both A dash coil and B dash coil have the same omega angular velocity value, and then let now the coil A take the positions where 0th point at the time condition 0, whereas the coil B is behind to that point, so it has some values, which means that the area of the cross sectional values. So after considering over this, now we are going to have the equation. Normally we have the induced EMF equation as a E is equal to Em sin omega t. For here the B dash coil have some gaps over there, so this gap will be notated in the term to the of omega t minus alpha. So it is achieved because of the since A started from the 0th position, whereas the B starts from some directional gap, so that only I have mentioned with respect to the of an alpha value. So now we are going to have this phase angle between this EA and EB. Here this A denotes the negative sign for the EB is lagging towards EA, so which means that induced EMF EA and induced EMF BB, whereas this induced EMF is something lagging to that of EA, which means that it doesn't start at the position of 0, it gets start somewhere else from the of 0, so that only I am mentioning this lagging as a EA. So now the EMF induced in the coil be taken at the reference condition. We are going to take the equation for the induced EMF obtained in that coil B, we are going to take as a Em sin omega t. So this lagging and the leading quantity, whereas which tells us the start and the progress behind the quantity under the reference is whereas this leading quantity tells us about the program ahead of the quantity under the reference, whereas the progress is behind the quantity under the reference, which means that it is lagging or it is in the ahead position. That is has been mentioned over this lagging quantity and the leading quantity. So thank you.